All right, so on the other day, we covered reviewing how to graph inequalities. So just real quick, let's just remind everyone. If we have greater than, we use an open circle and we shade numbers to the right on the number line. When we have greater than or equal to, we use a closed dot and shade to the right. And remember, with our symbols, to tell the difference, if it's equal to, it has the little line underneath the symbol, okay? For less than, open dot, shade to the left. And for less than or equal to, a closed dot, also shade to the left. And if we write our inequalities with our variables on the left-hand side, then the inequality will point the same direction that your graph is pointing, right? So we always want to try to have our inequality on the left-hand side because then they match. And so then it makes it easier for us to make sure we are doing this correctly. Now, when we went over solving with addition and subtraction, right, we used numbers to check our solution to make sure we were shading in the correct direction. When we solve inequalities with multiplication and division, it's even more important that we make sure to take time to do that step. Okay, so if we go ahead and look, and again, the nice thing about solving inequalities is that we're using the same rules that we used to solve equations. So here, if I see that x is divided by 4, okay, to get rid of dividing by 4, I do what?
Multiply by 4.
Okay, we're going to multiply both sides by 4. Okay, right? What I do to one side, I have to do to the other side. Because then on the left, okay, we're left with just the x. And then on the right, we have the 12. Now, before I write my inequality here, let's go ahead and look at what our number line looks like. So again, our solution becomes our endpoint. So 12 is going to be the endpoint. If we go back to our original inequality, it said, it was here, less than or equal to. So what kind of a dot do we want to make sure and use? A closed dot, okay? So we're going to use a closed dot. Again, I'm putting my graph above the number line. You can put it right on the number line. It's just sometimes harder to discern, but if you can use different colors, it's fine. All right, so we're going to pick a value that's not our endpoint. So any number that's not your endpoint to see if it's a solution or not, to know which way to shade our graph. So what is a number that is not our endpoint that we could use to substitute? Any number.
Maybe 14.
14. Okay, so if we put 14 in here, 14 is to the right of 12. Okay, so I'm going to go ahead and substitute that in. Let me move this over a little bit so I have a little more room. So I'm going to substitute the 14 into the inequality. And then simplify. And 14 over 4 is 3.5. Okay. Is that less than or equal to 3? No, right? So this is not true. So 14 is not a solution, right? So if we pick a number and it ends up not working, we know that's not a solution. So are we going to shade towards the 14 or the other way?
The other way.
We have to shade the other way, okay? And then we can write in our inequality. So this inequality is showing that x is less than or equal to 12, okay? The nice thing about when we're working with inequalities, as long as we prove one is not a solution, that means that everything else on the other side would be, okay? We don't have to prove more than one, and we don't have to disprove more than one. Just showing that the 14 is not a solution is enough proof and justification that everything less than 12 is a solution, okay? Eventually, if you stick with mathematics, you will learn how to prove that and you'll show it. But for now, just trust me that that's enough. You only have to show one. All right, let's look at the next one. We have x over 7 greater than 2. So just looking at the question, we can already answer what kind of a dot do we need to use? Open. So sometimes you might want to think about that ahead of time and just put on top, open dot, just to remind yourself. So you could do that at the beginning like we did just now, or you could do it when you're ready to graph. Either way is fine, okay? Personal preference for that. All right, so now we have x divided by 7 is greater than 2. To get rid of dividing by 7, we are going to multiply. Beautiful. Multiply. Okay, so now on the left-hand side, I'm left with x, and on the right-hand side, I'm left with the 14. Okay, so we're going to wait to write our inequality until we check it with our graph. Okay, so we draw our number line. For us, for Ms. Mason and myself, you only have to do the end point and then whatever point you're checking. You don't have to label 10 numbers or anything like that. You know, some teachers I know require more, but for us, we only require the end point and then whatever number you're going to check with, or if you do more than one number. All right, so what number do we want to check with? 3? Okay. Can we pick something that's evenly divisible by 7? So a multiple of 7. It just makes it easier. 28? Okay. And the reason why I'm doing that is because we're going to have to divide. So like here, yes, we could do a fraction, but it's easier if we have integers just because I think most students are more comfortable with integers. All right, so, okay, so we'll try 28. Oh, I'm sorry. We needed an open dot above the 14. So I added my open dot. And now I'm going to try substituting in the 28. Okay, so we have 28 over 7. And what is 28 over 7? 4. Is 4 greater than 2?
Is 4 greater than
Does someone have a question?
Yeah,
Josue, go ahead.
Yeah. So when we choose a number that's not the end point, is it easier just to do like a multiple of the, like for example here, a multiple of 7? That way it's not a fraction.
When you're dealing with division, yes. Now, if you're not sure, you can always just pick any number.
All right, thank you.
Yeah, and honestly, a lot of the time, if I'm dealing with multiplication and division, or even when I'm not, I use 0. As long as the variable is not in the denominator, 0 is like the easy, or 1. 0 and 1 are like the easiest numbers to deal with. So those are often, as long as they're not my endpoint ones I pick, but you can pick anything. And if it is division, then using a multiple is just easier because then you're doing a math fact as opposed to having to remember how to deal with fractions or decimals. All right, good question. So again, so this one, it was true, right? 4 is greater than 2. You're welcome. So 28 is a solution, so we shade to the right, and our final answer is that x must be any number greater than 14. All right, our next example is 1/3 x is less than 2/3. So remember, when we're dealing with a fraction, the numerator means multiply, and the denominator means divide. So in order to eliminate our fraction, we're going to do the opposite. All right, so to eliminate this fraction, instead of multiplying by 1, I'll divide by the 1. And instead of dividing by the 3, I will multiply by the 3. Okay. A little easier to see. And then, of course, what I do on one side, I'm going to do on the other side in order to maintain equivalency. Okay? So now on the left-hand side, I'm left with my variable, x. On the right-hand side, if you multiply the fractions, again, we can either multiply and then simplify, or we can simplify and then multiply. So we can either do 6 over 3 is 2, or we can cancel out the 3's and get 2 over 1, which is also 2. Okay, so we're going to end up with the value of 2 here by multiplying those fractions. All right, so then our endpoint is going to be the 2. Okay. And what number do we want to, oh, I'm sorry, what kind of a dot do I have? Open dot. Okay. And what number do we want to use to check? What do we think? Oh, go ahead, Josue.
Is it 6
Is
over?
it?
Go ahead.
I can't really. Oh, okay. Is it a 3 or a 2?
3, yeah. So the first one is 2 times 3 is 6. 3 times 1 is 3, which simplifies. In the second one, I canceled the 3's, so I got 2 over 1, which is also 2. So remember, when we're multiplying fractions, we can simplify and then multiply, or multiply and then simplify. Either one works.
All right. Thank you.
You're welcome. All right, what number do we want to use for our check? Either a multiple of 3 or 0, right? Because we have this 1/3, which means we're dividing by 3. So what do we want to pick? Anyone?
Hermione says 6.
6? Okay, thanks, Harmony. All right, so we're going to try 6. I'm kind of running out of space for these. Okay, so I'll do it right here. So 1/3 times 6. Okay. And 1/3 times 6 is 2. Is 2 less than 2/3?
No.
No, so not true. Not a solution. So we're not going to shade toward the 6, we're going to shade the other direction. So we want x as less than 2. Okay. And then for D, they have the variable on the right-hand side. So we can either simplify and solve and then flip it, or we can flip it first. What do we want to do? Do you want to flip first and rewrite it, or do you want to solve it and then rewrite it?
Hermione says flip first.
Flip first. All right, thanks, Hermione. So what we're going to do is we're going to flip everything. So instead of it being 5 greater than or equal to x over 2, we're going to rewrite it as x over 2 and the 5. And then because we flipped everything, we're also flipping the middle. Okay, so the big side of the inequality is by the 5. So it's going to stay by the 5 until we do any other work. All right, so to solve this one, we're going to multiply both sides by 2. So then I have x, and I have a 10. Draw our number line. Okay. Identify the endpoint. Do we have an open dot or a closed dot? Closed. All right, because we have that equal sign up here. All right, now a number that's not 10.
20.
Okay, I heard 5 first, so I'll use 5. So if we put 5 in here, and I'm going to use my original inequality to check this one. Just in case when I rewrote it I did something wrong, I want to go back to my original. So I have 5 greater than or equal to 5 over 2. What's 5 divided by 2? We get 2.5. Is 5 bigger than 2.5? Yes, it is. So that is a solution. So our inequality is x is less than or equal to 10. Okay. Any questions about these examples that we've done so far? Okay. We're going to do a couple more examples together, and then we're going to do some practice. All right, so here we have x divided by -5 is greater than 4. So if we see division, we're going to multiply. So we're going to multiply by -5. Okay. So then I have x on the left, and I have -20 on the right. Okay? So we draw our number line, identify our endpoint. Okay. What kind of a dot am I going to use? Open dot. Okay. And then I need a number that's not -20, preferably one that's divisible by 5. 15. Okay. So if I substitute 15 for x, okay, what is 15 divided by -5? -3. Is -3 greater than 4? No. So this is not a solution. So instead of shading towards the 15, I'm going to shade away from the 15, so to the left. So my inequality is x is less than -20. Okay. All right, let's look at example B. Here I have -x over 2 is greater than or equal to 6. When you have a division or a fraction like this and it's negative, the negative can be in the numerator, it can be on the side, or it can be in the denominator. It doesn't matter, okay? You always want to get rid of the negative. It can be in any one of those 3 places, and you still want to eliminate it to get the variable isolated. So we're going to multiply by -2. Okay? So that on the left-hand side, I'm left with x. And on the right-hand side, 6 times -2 is -12. Okay. Negative. Okay. What kind of a dot do we use for this one? Closed. Okay. And then we're going to pick a number that is not -12, preferably an even number that is divisible by 2. 8. Okay. So 8 is over here. So we're going to try substituting in the 8. Okay. So if I have 8 greater than or equal to 6. 8 divided by -2 is going to be -4. Is -4 greater than 6? No, so not a solution. So we shade it this way. So then what's our inequality? X is what? What is this showing? X is less than or equal to negative 12. Does anyone notice anything different between the two we just did and the ones we did above it? The inequality is switching. Sorry, go ahead.
I was gonna say that they're negatives, so integers. Maybe.
Yeah, so here we're dealing with multiplying by negative integers, and the inequality switches. Okay, and that's a rule, that's a property. When you have an inequality and you're multiplying or dividing by a negative number, your inequality will switch. Okay, and that's what's up here at the top of the page. Okay, so here, if we multiply, then the inequality with a positive number, nothing, it's the same. If it's negative, the inequality will change. Okay. All right, let's do two more. Let's just show that it also works for division. Okay. So we're going to skip to example 4 on the back so you can see. So we have examples 3 and 4 are division problems. The top deal with, let's do B right here. So I have 4a less than negative 12. Okay. So the number I need to divide is 4, right? Is that a positive number or a negative number? The 4. The 4 is positive. So let's see what happens with my inequality, because the 12 is negative. So if I'm dealing with a negative number, do I automatically have to switch my inequality? So here I have a, and here I have negative 3. Okay? All right. So we have this. We have our endpoint, open dot, negative 3, because our inequality was just less than. So let's pick a number that's not negative 3. And we're multiplying, so we can pick any number we want. What number do we want to use?
Harmony says
9. All right, thank you, Harmony. So that would be right here, 9. Okay. So if I substitute that in, 4 times 9. 4 times 9 is 36. Is that less than negative 12?
No.
No, so not a solution. So I shade away. So even though the 12 is negative and my answer my endpoint is negative, did that change my inequality? No, it's still less than. It only changes if the number you multiply or divide by change. So if it's easier for you, don't even try to think about that. Just do what we've been doing. Plot your endpoint, pick a point to check, and then write your inequality from your graph that you know to be true. All right? So often students try to use rules and tricks and things to make it go faster without truly understanding them. You have been able to successfully solve and graph and write inequalities without trying to use a trick. So if the trick makes sense to you, the rule, and you can use it, great. If not, don't worry about it. Okay? Just because there's a negative number doesn't mean it changes. You have to be multiplying or dividing the variable by a negative. Any questions about solving inequalities with multiplication and division? All right.